Okay, so we're starting packet three, the cardiac cycle. And our third objective here to identify all phases of the cardiac cycle, understand origin of pressure, and describe the relationship between pressure and volume. All right, so let's think about, all right, okay. The overview is looking at the phases of the cardiac cycle. There are four phases that we're going to speak about, and it's important to know what is happening in all four ventricles in each of these phases. Also important to think about what's happening with the valves in between the chambers during the phases as well. We're going to speak about atrial and ventricular pressure and how they're changing. It's also important here to think that the opening of valves is a passive process, so the pressure changes is really what controls the cardiac cycle. We're going to speak about pressure in the aorta specifically, just because it's so important to the overall circulatory system and the mean arterial pressure, et cetera, which we can detect in the aorta. We'll speak about the ventricular volumes, how we have filling of those chambers, emptying of those chambers with the cardiac cycle, and then how all of that comes together to form the two heart sounds, right? The heart sounds, which are the closure of the valves, respectively. So let's start by looking at the cardiac cycle as a whole. These are the events associated with a single complete heartbeat. So whenever you're listening to the heart, auscultating the heart, you'll hear the lub-dub, lub-dub. So what are the events that are happening with each of those single beats? And especially what is happening with the valves? What is the pressure change that's allowing the valves to open and close during the cycle? Now, there are going to be two main periods, the systole, which is ventricular contraction, diastole, which is the relaxation of the ventricle. So notice that when we speak about the cardiac cycle, we're pretty much taking the optic of the ventricle. We're looking at the perspective of the ventricle and not the perspective of all four chambers, although we still need to consider what's happening in all four chambers. But the terms like contraction, relaxation, is from the perspective of the pressure changes in the ventricle. Now, we discussed this concept previously, the fact that valves open passively when the pressure changes. So for the AV valves to open, the atrial pressure must exceed the ventricular pressure, and then they open passively. When that pressure is no longer higher, they'll close passively as well. The semilunar valves open when the ventricular pressure exceeds the pressure that is in the artery, be it the aorta or the pulmonary artery, right? So those pressure differentials are crucial for keeping the cardiac cycle going. Let's begin with the first phase of the cardiac cycle. And this starts sort of in the middle of diastole, but this is called ventricular filling. And here we're at the midpoint of the ventricle filling to its maximum capacity. We're going to see the venous return be important here because venous return is what has come back to the atria, and then that is what is being filled down into the corresponding ventricle. So the volume of blood coming back to the heart is extremely important for determining the ventricular filling. The AV valves are going to be open here, which makes sense because the ventricles are filling, which means that they're also in a relaxed state as opposed to being contracted. And we're also going to see the pulmonary and aortic, or the semilunar valves, being closed, which again makes sense because the ventricle is relaxing, it's not ejecting. It doesn't make sense that the semilunar valves would be open. So they're closed to keep that blood filling into the ventricle. And this is pretty much a passive process until the very end when the atrium begins to contract. All right. So here's the different events that are associated with phase one. First off, it's mid to late diastole, so mid to late relaxation of the ventricle. Notice AV valves are open, and notice that the ventricle goes is spilling the blood from the atria to the ventricle. Now, towards the end of that, notice that the atria is almost empty, and as it empties, it's going to squeeze towards the very end of diastole to contract to get that last bit of atrial volume to move down into the ventricles. If we look at some of the other events taking place, we can see the aortic pressure is low and dropping, which makes sense. The aortic valve is closed. So there's no pressure, or there's no blood moving into the aorta, so there's no pressure. Pressure is dropping off. In terms of the ventricular and atrial pressures, those are rising. Ventricular pressure rises not so much because of contraction yet, but because of the filling. As blood or volume moves down into the ventricle, the pressure there will slowly rise. And then atrial pressure will follow because atrial pressure will be increasing. And then towards the very end, it's going to slightly contract to spill that last bit of blood down into the ventricle. If we look at what's happening with volume, and remember, volume is from the perspective of the ventricle. So volume should be increasing as the ventricle is filling. And then we'll speak about the heart sounds and the EKG findings on this towards the very end. All right. Phase two. So phase two, now we have an isovolumetric period. And isovolumetric, the term literally means same volume. So in this phase, you want to consider that because the volume is the same, then none of the valves are going to be open. Volume is not changing, but the pressure is rising as the ventricle contracts. So it's an isovolumetric period, but it's a period of contraction as we prepare, excuse me, for the ejection phase. Okay. And so we want to think about here that the pressure in the ventricle is not high enough to open the semilunar valves. So as that rises, we're going to then see the opening of the aortic valve and the pulmonary valve where blood can leave the ventricle. Okay. So the AV and semilunar valves are both closed. There's no blood moving between any of the chambers, but the ventricles are contracting in preparation for ejection or phase three. Phase three, which is ventricular ejection, this is the rest of systole. So systole, which is the contraction of the ventricles, starts in phase two, and then it ends in phase three. Now we have enough of a pressure differential, for blood to leave the ventricle. Pressure is higher in the ventricle than it is in the artery, and so now it's going to be able to open up the semilunar valves passively, and blood can leave the ventricle into the artery. Okay. Now, towards the very end of this, the semilunar valves are going to close after ejection occurs. So after blood leaves the ventricle, remember, volume is going to be associated with pressure. So as that volume of blood is moving out of the ventricle, pressure is going to start dropping. And as the pressure drops, now we no longer have the pressure gradient in the ventricle, where the pressure in the ventricle is higher than the artery. So now the semilunar valves close towards the end of ventricular ejection. All right, looking at the state of our valves here, AV valve is closed because the ventricle is contracting, so the semilunar valves need to be open, whereas aortic and pulmonary valves are open. If we look at the pressure, it's going to start off high as the ventricle contracts, but then as blood leaves the chamber, that pressure is going to drop off as volume leaves the chamber. And then in terms of the artery, the arterial pressure will pretty much remain low because the AV valve is closed. All right, so there's not much activity happening in the atria in phase two and phase three. If we look at the volume, volume drops all the way off. Now we're ejecting. All of the blood that we spent time filling in phase one is being ejected in phase three, and so volume drops off completely. Okay. Now we can see that the heart sound, which causes, or the first heart sound, is caused by the closure of the valves that happens in phase two. And we'll see that the second heart sound is going to be caused by the closure that happens in phase four. So the isovolumetric periods where the valves are closed, as soon as those valves close, the shutting of those valves closing is what is going to create heart sound one and heart sound two, respectively. Okay, let's go to the last and fourth phase, the isovolumetric ventricular relaxation. And you can consider this to be the exact opposite of phase two, which is isovolumetric ventricular contraction. So here, same thing, all four valves are closed. Now, this means that blood is not moving across any of the chambers. This is the beginning of diastole, and this is from the dropping off of blood and pressure in phase three. Now we're going to see the ventricle is going to go back to a relaxed state. So the pressure here is going to drop, but it's not low enough to where the AV valves open up yet. The AV valves and semilunar valves are both still closed. But as that drops low enough, we're then going to see it's lower than the pressure in the atria, and then the AV valves will open up once again, which starts phase one of the cardiac cycle right from the beginning. So this is where the pressure in the ventricle is decreasing so that it will be lower than the pressure in the atria, and we can start phase one, which is the filling when the AV valves open up again. So looking at our phases here, both valves are closed, or all four valves rather, are closed. And we're going to see the aortic pressure slightly increase. It's going to decrease and then slightly increase. This is called a notch or a dichotic notch, which is a reflection of the closure of the aortic valve. So as that blood leaves the aorta, and then as the valve closes, there's going to be a back swoosh or a backlog of blood that hits the back of the closing valve. So that creates this slight dip and then slight spike in the aortic pressure, right? This is called the dichotic notch. In terms of what's happening with the ventricular pressure, that's dropping off, which makes sense as we are in ventricular relaxation. And then the atrial pressure is going to slowly start to rise as we prepare for phase one or diastole all over again. The volume is going to be the same. Notice that in phase two and phase four, volume doesn't change because all four valves are closed. Now, while we speak about all four valves being closed in phase two and phase four, you'll sometimes see an option or one of the distractors on questions saying all four valves are open. Notice that there's never a period when all four valves are open. Because of the pressure gradients that we discussed, that is impossible. It's impossible to ever see all four heart valves open at the same time. That just wouldn't make sense, right? We can see all four closed in phase two and phase four, or we can see the AV valves closed in phase three as the ventricles eject, and the semilunar valves closed in phase four as the ventricles are filling.